This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
In legacy governance and global finance, over 80% of transactions suffer from critical information asymmetry. Cross-border capital deployment is bottlenecked by manual verification, creating prohibitive latency across the entire system. Current Layer 1 and Layer 2 scaling solutions force a structural compromise. To increase payload capacity, networks sacrifice decentralization. To maintain distributed consensus, they strictly limit their throughput. With the integration of large language models into enterprise workflows, data processing requirements are scaling exponentially. Processing this intelligence demands a substrate that can handle massive throughput while remaining strictly GDPR-compliant to prevent monopolistic control over verified data. The existing infrastructure cannot process verifiable business intelligence at this scale. Attempting to do so inevitably introduces trust-based bottlenecks, breaking the cryptographic guarantees. Yellow Chain resolves this through a hybrid Layer 1 and Layer 2 protocol, instantiated directly on the Internet Computer Protocol, or ICP. This diagram displays the network's core telemetry. The protocol sustains over 10,000 transactions per second, achieves sub-100 millisecond latency, and supports more than 1 million concurrent users. To handle the heavy payloads of AI-verified intelligence natively on-chain, the network requires and maintains a distributed storage capacity of 50 petabytes. This performance is achieved by coupling a distributed canister architecture with a proprietary consensus mechanism known as Proof of Future Value, or POFE. POFE is a system that cryptographically verifies the predicted economic contribution of data before settling it. Coupling these systems, the network functions as a deterministic state machine. It automates the distribution of value globally, without human intervention or latency. This 3D blueprint shows the base layer, Canister smart contracts. They bundle compiled code and memory state natively on-chain. This structure enables a reverse gas model. Canisters pay for their own execution. Finally, HTTP outcalls allow direct, secure interaction with Web 2.0 data sources. To manage this data at scale, the Yellow Chain protocol schema relies on specific parameter definitions written in Motoco and Rust. This table maps the core data model, defining the UUID and principal owner, and routing execution to stable memory for persistent account updates. Transaction history is recorded in an immutable append-only log, while a B-tree indexing architecture optimizes for fast, ordered access during heavy read cycles. Under a strict 100 millisecond retrieval constraint, these specific data structures are mathematically essential to maintain strong data consistency across the network. The routing and storage core of this ecosystem is the Global Business Intelligence Ledger, or G-BIL. This state transition pipeline begins with multi-source data ingestion. Raw data moves into AI processing, where neural subsystems format the information. Next, zero-knowledge verification establishes finality without revealing underlying data. Finally, the validated state executes a stable memory commit, permanently settling the intelligence. During the initial input stage, the system enforces strict schema validation rules to reject malformed data before computational resources are spent. Before any execution proceeds, the protocol automatically clears balance verification and permission checking logic, ensuring the executing canister holds the required resources. By forcing all payloads through this automated commit pipeline, the protocol guarantees the data is cryptographically verified truth before it ever reaches ledger settlement. Unlike traditional proof-of-stake models that ignore the data payload's intrinsic value, the right side details proof of future value. This predictive consensus model uses ZK snarks and BLS cryptography to evaluate, aggregate, and strictly verify intelligence data. Following the POFE circuit flowchart, data ingestion triggers an internal Oracle architecture, cross-referencing inputs against verified parameters. The payload enters the proof verification system, generating a cryptographic score for its economic contribution. Finally, automated smart contracts instantly execute corresponding reward distributions. Proof of future value shifts the mechanics of network consensus. Rather than expending resources on arbitrary computational puzzles, the network directs its energy strictly into predictive value verification. Zooming out to the macroscopic network topology, the central ledger expands into a globally distributed structure, formally defined as the National Canister Constellation model. It establishes sovereign data stores. Where legal frameworks require it, data processing and execution are siloed and maintained strictly within local jurisdictions. To maintain cohesion, secure inter-canister communication protocols route these localized states back into the global ledger for network-wide coordination. Operating under a localized execution and global routing dichotomy is the only viable architectural solution for ensuring strict cross-border regulatory compliance with frameworks like GDPR and the Markets in Crypto Assets regulation. All system state transitions and protocol upgrades are governed by the Service Nervous System, a specialized DAO architecture native to the Internet computer. The SNS utilizes liquid democracy, where voters delegate weight to expert nodes, while an AI subsystem provides neutral risk summaries. Submitting a proposal requires a hard lock of 100,000 YCT. Execution demands a 40% quorum, a 66% supermajority, and a 48-hour time lock. This chart details the dual token model, separating the YCP utility token from the YCT governance token. Distribution allocates 15% to the team, 40% community, 25% reserve, and 20% partners. A 4-year lockup period for the team allocation ensures long-term alignment. Deterministic smart contract governance entirely removes human latency and administrative overhead from the execution of protocol upgrades and treasury management. Yellow Chain operates as an autonomous value curation engine, executing logic and state transitions without the need for external triggers. This master schematic tracks the deterministic lifecycle. Raw data is refined by POF circuits, settled permanently on G-BIL, and governed by the SNS DAO. Legacy asymmetry stems from opaque silos. G-BIL's transparent verification pipeline ensures every participant sees the exact same cryptographically proven reality. The protocol achieves what earlier networks could not: the successful merger of scalable, heavy artificial intelligence compute with zero-trust cryptographic finality. For protocol developers and market participants, the Yellow Chain stack provides the definitive infrastructure required to guarantee equitable, automated economic participation at a global scale.